everybody, so this is part 2. We're looking at of 8.9.2. Again, we're looking at graphing those geometric sequences. So remember last time we talked about how to translate or move it left or right or up or down on our graph, on our coordinate plane. So now we're just going to be looking at what happens when we change A. So when we changed H, or when we changed H, so X minus H, that gave us a movement, a translation left or right on the coordinate plane right here. So we went, this moved this way or this way. When we changed K, it moved it up or down on the coordinate plane, up or down the y-axis. Now we'll be looking at what happens when we change A. So we're breaking it down into different components because we want to see what those results will be when we do that. So first of all, graph function of X, and again, we're changing this. We're not using graphing calculators, we're using brains. Okay, so turn your brains on if you haven't done that already. Time to go. All right, so graph of the function f of x equals 4 to the power of x. So when x is 0, that's 1, right? Put that right here. When x is negative 1, that would be 1/4. Okay, when x is negative 2, that would be 1/16. Okay, and you can see that this line's getting closer and closer to the x-axis. It never actually touches the x-axis though. All right, and it will go on infinity in that direction, never touching the x-axis, but getting very close. So close that the naked eye couldn't tell the difference. All right, how about when it's equal to 1? Okay, that's 4 to the power of 1, which is 4. Okay, and then let's just do 2. Oh, we're not going to be able to graph it because it's going to be 16. That's going to be way up here. So if we just follow that graph, there, that's what we get. Okay, now we're going to change A up and see what happens. All right, so now we're going to graph G of X. So our f of x is in black, and our g, our function of x over here, is in brown. Okay, so let's see what happens when you do that. Again, you just need to create a couple of data points so that you know what you're graphing. So we'll give it x, g of x, okay. And like this one, I did 1, 2, 3. I did 4 points. So let's just do 4 points. Obviously, I like 0. I like negative 1. Let's do negative 2, negative 1, 0, and 1. Okay, and if we can, we'll go up to 2. Well, we'll see. All right, so let's start with 1. So if we have 3 times 4 to the first power, okay, 4 to the first power is 4. 4 times 3 is 12. Okay, see, so that's already too high. All right, how about 0? 4 to the 0 power is 1. 1 times 3 is 3. Okay, and I was doing that this whole time. I was doing this, but I was just doing it in my head. But so now we're actually writing it down. All right, how about negative 1? So 4 to the negative 1 is 1/4. 3 times 1/4 is 3/4. Okay, now the top's going to stay the same, and the bottom is just basically 4 to the second power, 16, so 3/16. Okay, so if we're looking at that, negative 2 is 3/16, which is probably a little bit higher than this one. 3/4 is actually, I would say, probably right about there, and I'm just eyeballing it, so if it doesn't happen to be the right, if it doesn't happen to be the right position, it's okay. I'm just eyeballing it here. 0 is 3. All right, and then 1 is 12, which is going to be up here. So we're not even going to hit 1. We're probably going to hit like right around there. So this line is kind of basically the same. All right, and it shares that point right there. Okay. All right, so boom, it was a little off, but there you go. That's what the graph looks like. So this is f of x, and this would be g of x right there. Okay, so you can see that the graph sort of stretches up a little bit. We're stretching it vertically. All right, we're stretching it up. All right, what happens when we do 1/2 times 4 to the x power? All right, we'll just use the same, our same terms here. So -2, all right, 4 to the -2 is 1/16. Half, 1/2 times 1/16 equals 1/32. Okay, so -2 is going to be even smaller than the 1/16, the original one. All right. All right, sorry, 1/2. And then for 32. 1/32. 1/32. All right, 4 to the negative first power is 1/4. Okay, 1/2 times 1/4 is 1/8. 1/8. Okay, so that -1 is 1/8, which is probably closer down there. All right, 0. Okay, that's 1 times 1/2. So 4 to the -1, or sorry, 4 to the 0 power is 1. 1 times 1/2 is 1/2. Okay, that's at 0. All right, and then when we get 1, so this one we're probably going to want to go a little bit farther out. When we get 1, 4 to the first power is 4. 4 times half is 2. Okay, so that's at 1. 1 is 2. Okay, let's see what 2 is. Maybe even 3. Okay. 4 to the second power is 16. 4 times 4 is 16. 16 times half is 8. Okay, that's 2 to the 8th power. That's where we're going to have to stop. Okay. Bam! And there we go. And I should have been doing that in green, because again, we're trying to change our color. It's just below the black line. Bam! There we go. And so you can see that it kind of shrinks our graph down a little bit, right? When we multiplied it by a whole number a, it stretched it vertically, and when we multiply it by a fraction or a decimal a, it kind of shrunk it down a little bit, pushed this graph down in order to hit these different positions. Okay, so that's how we do it. Compare the graphs. How is graph g of x related to f of x? All right, graph g of x is stretched vertically, and graph h of x is squished or shrunken vertically. Okay, so it stays in the same place, but we're just smushing the graph down or stretching it up. That's going to move it, obviously, but it's going to keep, the base is going to be the same, right? When we were doing the other ones, it really just moved along this line, left or right. And then we also moved it up or down this line, this y-axis line, up or down. So changing the h or the k moves it this way or this way. Changing the a is moving it, is squishing it this way or stretching it that way, okay? For a is greater than 0, how do you think the value of a affects the graph g of x equals a times b of x? If a is greater than 0, then the graph stretches vertically. Don't worry, that wasn't an earthquake, the door just shut. Okay, without graphing, explain how the graph g of x is, without graphing, explain how the graph g of x equals 4 times 2 to the x plus 1 minus 7 compares to the graph x 2 to the x power. Okay, so remember, when we subtracted, we moved the graph along this way when we subtracted this. And when we, sorry, let me just double check. I think I made a mistake. Yeah. Oh, okay. I'm sorry. I misspoke. And I was thinking here, that's why. Okay. So for that first part, if we're looking at the exponent, when we added, okay, the graph will be translated to the left. The graph will be stretched vertically. Okay, it'll be stretched, it'll grow up, okay, vertically. Translated to the right. And translated down. All right, so basically, if we had this, whatever this looks like in a graph, let's just say it looks like this, okay? It's gonna be stretched, so it's gonna be more of a vertical line, or the line's gonna look more vertical, and then it'll be translated to the right, and then it will be moved down. So this would be the actual new line. I mean, obviously I'm just eyeballing it. I'm not looking at I'm not looking at it accurately. I'm just trying to see like what's gonna happen. And I actually made a mistake. This will be to the right, or to the left, sorry. Okay. So, and again, because we're adding this right here, it's gonna move to the left, because as you go down here, it's going to make this number grow exponentially a little bit earlier than it would if we were working with a negative right there. Okay, so that's part 2, and we'll leave it right there, and we'll look at part 3 in a second. All right, peace.